Hi everyone, welcome to my channel Srinivasa Biology Tutorial. For this section to discuss NCERT Class 11 Biomolecules Part 5, that is classification and nomenclature of enzymes. Thousands of enzymes has been discovered, isolated and studied. So in the earth they have a number of enzymes, they are discovered and isolated. Most of the enzymes they are classified into as in different groups based on the types of reactions and catalysts. So the types and their catalyst based on they divide into as in a 6 classes. They divide into how many classes? 6 classes. Here within 4 and 13 subclasses named according to the 4 digit numbers. 4 digit numbers. The first one is oxidoreductase or in a dehydrogenase enzyme. The first one is oxidoreductase or dehydrogenase enzyme. This enzyme which catalyzes oxidation and reduction between as a two substrate S and S dash. Example here, S is reduced, S is oxidized. S is oxidized. So here what happened? X is oxidized and S dash is reduced. So they're completely, what happened? They change. Next, transfer. Here transfer is enzyme. What is the transfer? Is transfer. Here the enzyme is catalyst for transfer of one group like as in G other than hydrogen between the in a pair of two substrates. Example, here they having is S substrate G S dash. Here automatically G get transferred here to here. So this is what transfer will be takes place. So this kind of enzyme is called as what? Transferase enzyme. This total G to move from here to here, presence of enzyme is what? Transferase enzyme. Next, hydrolase enzyme. The enzymes catalyze hydrolysis of esters, ethers, peptides and glycosidic and carbon-carbon bonds and carbon, their halide and phosphorus nitrogen bonds. Mostly they are hydrolyzing of in a different bonds like as in a carbon-carbon and ester bonds, ether bonds, peptide bonds, glycosidic bonds to formation of that bonds. Next, the lyases. Next one is what? Lyases. See, these enzymes catalyze in removal of group substance. Mostly they help you as what? In a removal of in a their group of substrate by as in a mechanism one other than hydrolysis of in a is their double bond. So here to get complete to get removal of groups, that purpose this lyase enzyme will be to get help. Next, isomerase enzyme. Isomerase enzyme means the complete help to as in they change the structures, right? The including enzymes the catalyst interconversion of optimal geometric and positional isomerism. Okay, like as in a glucose is converted as in a fructose. Glucose is converted as what? In a fructose because the structurally that same is function is different. Like, and next last one is ligase enzyme. Ligase enzyme. The ligase enzymes to get help as in a linking together two components. Enzymes to catalyze joining of in a carbon oxygen bonds, carbon sulfur bonds, carbon nitrogen bonds and phosphorus oxygen bonds, etc. So these are completely different classification of enzymes. Next, cofactors. Next one is what? Cofactors. See in these cofactors, the enzyme component the composed of one or more several polypeptides. Here enzymes are composed of one or more polypeptide. However, these are number bases of which are non-protein constitute is called as any factors to bind with as an enzyme to make as a catalyst active, catalytically active. So here they having as when you take as a one particular enzyme, the enzyme they having as a two parts. Some they having as a protein, that is protein part is called as an apoenzyme. It is in a apoenzyme, and non-protein part is called as what? That is in a complete called as in a cofactor. Now, see this instance of protein position of any enzyme is called as in a apoenzyme. Means I say that one only the protein part here within the enzyme. The protein part is called as what? Apoenzyme. This kind of the cofactor is identified as in a prosthetic group, coenzymes or metal ions. So in this total, the cofactors is divided into as in prosthetic group, coenzymes and metal ions. Now we see that as a prosthetic group. The prosthetic groups are organic compounds with as in a divided from as in that cofactors that they are tightly bind with as an apoenzyme. To complete to bind with as an a tightly bind with as an apoenzyme. For example, here peroxidase and catalase. Peroxidase and catalase, these are the two enzymes which as catalase is a breakdown of in a hydrogen peroxide to water and oxygen. So here H2O2 is breakdown into H2O2 is converted as what? Water molecules as well as in a carbon dioxide will be in that oxygen will be they get releasing. Okay. Now the heme is in a prosthetic group and a part of the active site of the enzyme. Here also heme group also best example for as in a prosthetic group. Next, second one is what? Coenzymes. The coenzymes are the organic compounds but associated with as in the apoenzyme that transcend usually according to during the course of in a catalyst. It is also to get bind with as in a tightly in the part in which region? At the in a apoenzyme region. The further more the coenzymes several cofactors the number of the different enzymes catalyst reaction. Here to get participate what? In a different enzymes they get participated and different catalysts also they get participate. Essentially the chemical components there may be the coenzymes like RNA vitamins. They given as in a the coenzymes and nicotinamide adenosine dinucleotide NAD and NADP they contain as a vitamin niacin. Here NAD contain as what? Niacin is present. Like okay, these are the completely coenzymes. Next one is metal ions. The number of the enzymes required for as in metal ions for their activity from that in a coordination bonds with side of the change activity side and the same time the formation of one or more coordination bonds with as in a substrate. So when the enzyme action will be there going on to get formation of more than one or two or more components they require as in these metal ions. Example they given here, zinc is the in a cofactor for the in a their protectively enzyme that carboxypeptidase, the carboxypeptidase enzyme to get mostly help. Okay, next here after the catalytic activities is lost when that cofactors are removed from the in a enzyme which in a takes place that play in a crucial role the catalytic activity of the enzyme. So in this mostly the enzyme activity that to work that depend upon the in a mostly enzyme activities. Okay, this is in completely the biomolecules chapter. Okay, thank you for watching.